Great. Thank you so much, Bruce. And yes, super excited to talk to this group. So again, my name's Laramie. I'm the head of the sales team at LYT, and we're pleased about this partnership that we have with Seattle. So we are a cloud-based TSP and EVP provider that's based in California. So if you go to the next slide. Um, we are we are hardware free, completely cloud based, and I'll talk a bit about how we use machine learning to improve the accuracy of our algorithms and to make sure that we're able to drive those really important metrics that Bruce was talking about. And so obviously intersections are becoming more unsafe. You talked a bit about the metrics before, but this is something that we track on our side too, and it's something that we take very seriously, and is one of the reasons why um, all of us get up and work every day. Next slide. So Bruce touched on this, but EVP has come a long way since its first iteration with the optical detectors that had to require that line of sight. As Bruce said, it doesn't really work around corners or over hills, or if there's bad weather, or if just the detector hasn't been cleaned regularly. And this can result in inconsistent behavior across a corridor. Also, there's not great analytics on if it's working and what the efficacy of it is. So if we go to the next slide. So again, what a cloud-based solution offers is a more accurate ETA. So the way Light works is we essentially run a prediction algorithm. You and your fire departments and your EMS services have made tremendous hardware investments, both in the cabinet and on the vehicles. And all Light does is leverage those. So we use both real-time and historical travel patterns to run a prediction algorithm to predict when that vehicle will get to that intersection. And when it does, we make sure it gets a green light. So for something like even TSP, we can start to predict a vehicle's arrival up to 2 minutes in advance. And this is all just working with the individual controllers and leveraging the data standards like Bruce mentioned of NTCIP 1202 um, for EVP. So Bruce mentioned one of the drawbacks is it does require connectivity. That's true. For Light to be really successful, or for just TSP or EVP to be successful in general, it requires connectivity. It requires really high quality GPS, usually 5 seconds or less. And it requires the controllers to be able to speak in the communication protocol for EVP, which is NTCIP 1202. So as long as those three boxes are checked, it's something that can be deployed really, really quickly. Um, Outside of Seattle, I think we worked with the city of San Jose. We're on every signal in the city of San Jose for TSP. And for that, we were able to get our first 122 signals up and running for TSP in less than 90 days. So it's come a long way since requiring hardware, taking vehicles offline, getting bucket trucks up to the signals and closing down lanes. This can all be done over the air in days, which is really exciting. Next slide. So when you talk about cloud, obviously one of the things that comes up, one of the concerns that comes up is privacy and security, obviously. And so luckily for out of us on the call, there's a standard for that too. And so the the gold standard of the day is called SOC 2, and it's a rigorous privacy and security audit. And it's one that Light has gone through. We're going through it every year. And it's meant to show that it's the highest level of privacy and security, and we're really proud, at least for the moment, to be the only cloud EVP provider that has achieved this audit and this compliance. And it's about end-to-end encryption. It's about limiting hacking, and it's about Overall, a company-wide privacy and security. Next slide. So Bruce touched on this. This is kind of just a more generic architecture slide. So his was specific to how we've integrated with the systems in Seattle. But again, the way Light works is we take whatever is able to produce a GPS signal on the vehicle, whether it's dispatching software, CAT AVL, or just raw GPS. Connect that to our cloud, and that's where we're able to make our decisions about where and when to send our requests. We do have one device called the Maestro. You see that on the upper right. It sits at the TMC. It looks like a physical device, but it can actually just be a virtual machine that we can send a line of code to. And that gives us access to all of the connected signals. So we're not taking over phasing. We're not taking over any of the timing. We are just jumping in at the exact second that the vehicle is going to arrive to make sure that it gets a green light. And then we're able to resume signal phasing as quickly as possible. So it's not something that has to, restart with the coordination. We're able to really limit its disruption. Um, And so again, these are just overall benefits of cloud. Again, this technology has come so far in the last 30 years. And one of the benefits is being able to connect multiple jurisdictions. Emergencies don't know zoning boundaries. And so being able to connect multiple jurisdictions under one EVP brain so that we're able to leverage coordination where it may not exist across jurisdictions is a huge benefit of cloud. Also, just getting those automatic updates. It's something we make updates every week. And so whether it's to the interface that you see on the right, which allows uh, all stakeholders to see the real-time vehicle positions, and be able to track the success of the EVP of the EVP messages that are being sent. Also, just being able to set customized business rules all without any existing hardware. And again, any vehicle that Light or kind of any of these other companies can get GPS from, we can give preemption to. Next slide. So we talk a lot about AI and machine learning. It's one thing that Light is proud to be a responsible user of AI. And the way we use it is through something called route prediction. So at least in this graphic, you see the fire symbol in the kind of in the middle of the map, and you see the green vehicle in the lower middle. And what Light is doing is leveraging historical travel patterns to predict to predict the route that the vehicle will take. And so we would never clear a corridor, just have the vehicle turn right, and then clear that whole corridor, just have the vehicle turn left. We are only triggering the exact signals that we expect it to go through. So there's way fewer false positives. Um, and so this is something that we have a lot of data to back up the success of, so that again, we're not clearing an intersection that we don't believe the vehicle to take, based on all of the historical travel patterns that we have of every time there was a fire there and the truck was there, and it was noon on a Monday, which route did it take? And so we're able to, update this regularly and use our predictions to only clear the right signals at the exact right time. And so we have a quick video just showing a ride along of one of the vehicles in Seattle that's using Light's EVP. So there's no sound, so let's narrate it. But again, Light is able to preempt well in advance. And if we see the map in the lower right, again, this is the interface, the web interface that all project stakeholders get. So we're able to see the the signals that Light has access to. So it's just on that major corridor right now. And we're able to see both real-time signal phasing as well as where there's a preemption request. And that's where you see that kind of siren symbol going through. And what you'll notice on the map is the second the vehicle goes through, we remove that request. So again, normal signal phasing can resume as quickly as possible. And this is not an example of route prediction because it's just going straight through the corridor. Um, and we'll be able to see it kind of clear all these intersections. But again, being able to clear several intersections ahead of the vehicle just allows for much faster travel speeds, allows it to fully be clear of pedestrians, of cross traffic, so the vehicle can get through quickly and safely. I just have one other slide just showing some of our metrics. And again, the one on the right is most relevant, a 62% reduction in response times in Fremont. These are metrics that we're really proud of, and you'll see some of the other jurisdictions that we work with. And if you go to the next slide, this is just my contact information, but you can always go to LYT. Everyone says LIT, but it's actually LYT, LYT.ai, to learn more. And this is something that we're all really passionate about and would love to see if there's a positive impact that we can have on your jurisdiction as well. Back to you, Jim. Thanks.
We have some questions here. We have about 20 minutes left. And I'm going to get right to a couple for Bruce and Laramie, pardon me. What, if any, authorizing by the region was needed for emergency responder signal priority? Bruce or Laramie?
I think the question is referring to maybe other agencies within a region, other emergency service providers. And
sounds like it.
Can you hear me okay?
Yeah.
Yes. And to my knowledge, we have not really involved other agencies. In this particular area, there are occasionally emergency vehicles from another city, city of Shoreline or city of Bellevue might respond. And currently they would not be eligible for cloud preemption. That could be set up pretty easily though.
Yeah, and that's what I've seen from my side too, is if there is that motivation for mutual aid, having other jurisdictions come into your jurisdiction and use your preemption, that is a city to city or city to county conversation. But with all that we see in terms of the capabilities of newer controllers, it allows for a lot of flexibility within the system.
Absolutely. Another one for you guys. What guidance might you offer for other regions considering cloud-based signal preemption technologies for emergency response?
I would say do it. It's just a very effective way to get your emergency vehicles to the scene faster and safely. It does require NTCIP traffic signal controllers. So there is if you have older legacy equipment or proprietary type of firmware in your signal cabinets, then you may need to replace some software or equipment. And you need highly reliable communication. But other than that, you're pretty much good to go.
Yeah,
go for it.
Yeah, from my standpoint, we really encourage agencies that are thinking about it, jurisdictions that are thinking about it, to just pilot. There are a lot of opportunities because there's nothing in the cabinet, nothing on the vehicles. It's a pretty quick thing to spin up. And at the end of it, we really want cities to fully vet the system. Don't give it the easy intersections way out of town. Give it the challenging ones and try it during difficult times of day. And there is so much data that you can iterate really quickly. Try one strategy on Monday, try one strategy on Tuesday. And by Wednesday, you would have the data to see which is the best for your unique operating environment.
Absolutely. Question for you, Ryan, similar to Laramie and Bruce. What, if any, authorizing by the state was needed for use or use cases of drones?
A lifetime of paperwork filing. I would file more paperwork than I fly. and I always, I never wanted to be in that position, but yes, I will say the FAA has been amazing here lately with a lot of their efforts to get law enforcement underway. But I saw there was a question too for can DOT and law enforcement both use drone dock and with Caltrans in Alaska? The answer is yes. If I had to do a quick explanation of it, currently drone docks are being operated from state agencies under public and civil operations. Caltrans, for example, operates under Part 107 and Alaska operates as a public agency. Each individual agency that utilizes that asset needs to either have a COA, which is a certificate of authorization from the FAA, and prior training that allows for them to operate that system either from Skydio or DJI or any of the other dock manufacturers. So FAA is not the item that is, I would say, roadblocking it. A lot of it at the moment is this technology finally is getting authorized. We're seeing beyond visual line of sight operations opening up for many departments. It's really just how fast states are adopting it. Learning from their mistakes, failing, or as we're doing, partnering together with other states so that we kind of crowdsource this and all learn from each other at the same time, which is really the benefit of all of this is taking what
Absolutely.
works someplace else, making our own flavor, improving upon it, and sharing it back with the group. So hopefully that answers the question. Is yes, there are it's basically just installing these docks, installing these technologies, cloud first on a lot of these pushes, and getting the correct partners in line to start testing and deploying these systems.
Yes, thank you for that. So another one for you, Ryan. What has the public perception been to the use of drones for emergency response?
We've spent a lot of time, well, especially with this, it's like, hey, do you mind if we install this suspicious looking box in your neighborhood? Yes, I mean, we spent a lot of time, especially with Wrangell, where we had the landslide. We did have some folks that lost their lives in that landslide. And so we had to treat a lot of the data with sensitivity, but we did a lot of outreach with the community, with a lot of the students, with a lot of the folks of, hey, this dock is going out there, but what this is doing is it's checking to make sure ground's not moving. So we're not just showing up in these places, these communities, but we're making sure these communities understand, hey, that tool is keeping us safe. That tool is doing its job there. And we're definitely looking at that, especially with some of our SOAR initiatives, where we'll be installing these docks throughout Alaska, Hawaii, Oregon, and Washington, and testing these different environments. What works well in Western Alaska, with a limited population, probably will not work well in the heart of LA.
Sure.
I think that's exactly what we're looking forward to. Is we're going to fail our way through this together, find and learn from our mistakes, and continue building these. But public outreach is a crucial item so that folks are aware of what's inside that blinking box that's sitting here making a noise and takes off every couple of minutes. So
Yeah, I remember our first exposure to UAS drones was the city of Chula Vista in Southern California. The police department there, they were launching drones from their I guess police headquarters mostly for police activity, but ultimately were started to use it for traffic incident management. So we had a really cool collaboration with them for a while. I have another question for Bruce and Laramie. What future traffic signal upgrades may be a priority for existing signal systems before cloud-based EVP can be implemented?
I would just say reliable communication and an NTCIP traffic signal controller. That's it.
Okay.
Yeah.
Yeah.
I think one of the benefits of data standards is, I mean, Light and Cloud TSP would not exist, and EVP would not exist without data standards. And so it's just making sure that when you are looking for that signal modernization plan, that they adhere to data standards because they enable a lot of plug and play, a lot of a lot of interoperability, and so a lot of companies and a lot of folks talk about interoperability, but data standards are the proof of that. And so making sure that they can speak the same language to each other is key.
Yeah. What would you say to uh, what would you say to municipalities, owner authorities that are considering EVP? And I know TSP's been around a long time, and the old, original Opticom systems and all that before the cloud-based stuff that you guys specialize in. Um, and the reason I asked that question is because we don't know of too many jurisdictions, municipalities, like I said, and other areas that are employing EVP. Um, what Why is that, do you think? Or is it the cost overall or maintenance or all the above?
In my opinion, it's it's a lack of data, and I think without data, you don't see maybe how bad things are. You especially if there was a legacy EVP system that was bought, that was purchased and installed, you think you have something, but without the data to prove its efficacy, you don't. Um, you may not be motivated to look elsewhere. You can kind of get anecdotal evidence from fire chiefs, but without the data to prove it, you may not see how far the floor has dropped out from the system that you purchased maybe 20 years ago.
Yeah, yeah.
Hey,
And
Jim,
and who
I'm
was that?
sorry, this is Vaishali. There's a bunch of questions still in the Q&A. May I bring some of those up to
Didn't
surface for,
we didn't we field a bunch in the Q&A earlier?
right, when we answer them in the Q&A, it only goes to the person who has been asking the question more often. So we try to ask them verbally as well so that everyone can hear the response.
Okay. Go ahead, Vishali.
Yes, so one of the questions was from Sean Laffey. In addition to the observed increase in green time for emergency vehicles, have you also realized any other benefits that Laramie mentioned, such as improved response time? And have you encountered any challenges with using the cellular network to request green signals, particularly during high volume events like football games?
So it looks like
I don't know
Bruce
if
answered that.
I'll I'll chime in quickly. I think that answer only went to Sean. So for everyone's benefit, I'll repeat that. So the first question about reduction in fire response times. We've heard anecdotally the drivers are highly confident that they're getting faster response time. We have not investigated, but we can and we will do that from our dispatch data. Second question was, I think was asking whether at major events like a football game when there's a lot of cellular traffic, if there's any reduction in service or communication. And I haven't not aware of anything there. Our traffic signal communication is typically fiber optic that would be immune to that, but it's possible that the apparatus is competing with other cellular traffic. Laramie can probably speak to that better.
Yeah, and I can just say a bit under the hood is that that's one of the ways that we use machine learning is to kick out a lot of that GPS noise. Because especially where there's a lot of competing signals, especially in, urban canyons, you can get a lot of noise. And so that's one of the ways that we use machine learning is to kick out the sources that we see as unreliable in that moment.
And then there was a question about how long the video is stored. And if so, who could potentially make use of that in terms of the LYT video that you demoed?
Totally. Yeah. So I think our default is to store all this information for a year. But that's completely customizable based on jurisdictional needs. I know if there are insurance requirements, grant reporting requirements, all of those can be tailored, but off the shelf, it's about a year.
Okay. And I think there was also a question for Ryan on, given the large volume of data, how is the storage and processing of that data better managed? And I personally have a question of how, if any way, is that data being shared with the broader Alaska DOT enterprise for other uses?
Yeah, so that was kind of the problem that we walked ourselves into, is we gave everybody access to these data creation devices. And I'll be the first to tell you, we didn't know that we were going to redline all of our drives. I started with IT, was not big fans of us because we broke our network pretty fast. Shortly after that, we kind of went back to the drawing board where we structured, hey, here's all the data we're creating. Here's what can be stored. Here's what can be deleted. And so we went into that as we went into partnership with Esri, where they came in and kind of did a full system analysis of, hey, here is how we store items. Here's what goes into the geo database. And from there, we started breaking down a lot of the silos. Is now we can search all of our imagery that's created. As well as publish that to we have an Alaska Geospatial Council, which is all state agencies. So all imagery that's created by public agencies is available to the public. And so that then gets sourced up there from our image server. Same thing with video. Anything that is project related, we save for a year before it is deleted. But that's kind of where we're pushing a lot of it is, hey, we are bringing everything, we're processing it on-prem. So that's another big item is, unlike the rest of you guys, I saw there's a couple folks from Alaska, but the rest of the folks in the contiguous United States, we don't have fast access to data centers. And so we have started building smaller edge compute centers around our state that we can send data to, process it, cut all the fat off, and only lift the final product to the cloud or Azure Washington Data Center West, which cuts down on a lot of our ingress costs to the cloud by not putting all of the raw imagery, putting the final product, moving it around. It's just a simple lift and we're done. So where we're limited on bandwidth to the cloud and those items, edge compute, and having that pre-processing has done a lot for us into the geodatabase and environment that we have there for sharing all of that information, both geo-rectified and orthomosaics and video across our enterprise system.
Very
Well,
good strategy.
with that, we have 4 minutes left, and I want to first thank Ryan, Bruce, and Laramie for their time and outstanding presentations to the National TIM community. We still have over 140 participants with us today, and a huge thank you to all of them. I always take a couple looks at the participant list, and I see many of our champions, our partners across the nation that are interested in everything that you guys do. And I want to, besides sharing these resources here, these links to various resources, I want to say that the next 3 Talking Tims webinars are going to cover topics from the Everyday Count 7 Next Generation TIM Technologies for Saving Lives. Our contract team is already preparing of the 46 states, I think it is, that participated in EDC 7 Next Gen TIM. Over those months, starting in June, July, and August, the Talking TIM platform that we're on here today, Adam, and of course, Executive Director Nick Ramphos, that was also joined us today, are very kindly going to let us conduct those EDC 7 webinars over the next 3 months. So make sure, if you're not registered, that you do. That top URL there, and all the rest of those URLs there contain a lot of very important information, including the self-assessment, by the way. Let's see. Vishali,
Yeah.
anything else we missed? We got 2 minutes and then I want to say goodbye.
No, I think there were a couple of questions about the training site, and it will be live within the week or so, and you'll get a formal announcement from the team on that. And I know there
Yeah.
were some questions we didn't quite get to, but we'll save that for a future future effort, I presume. So,
Yes.
great
And
presentations today. Great
yeah,
information.
indeed. And many thanks to you, Vishali, for all your work making this happen. And I think that's a wrap. So everyone stay safe, keep doing great things, and head on a swivel, as we say. Out of your car on our nation's roadways, a very dangerous place to be. So God bless. Take care, everyone.